Hello and welcome to this discussion on the topic of materials master data cleansing, an issue that has grown in prominence as companies seek to increase service levels and productivity and to reduce costs. In this conversation, we'll be sharing some stories and lessons learned from having helped many companies in engineering heavy industry sectors to overcome their challenges with this problem. To bring the matter to life, we'll take a closer look at one example in particular, deep diving into the journey and experience of one major company as it sought to navigate the turbulence of digital transformation in a disruptive economic environment. A little while ago, an energy company operating in Latin America was concerned with the service levels and costs it was getting from its MRO inventory. Like many such firms, the company was facing stoppages because of a lack of spares, while at the same time they were spending too much on inventory. With the wave of digital transformation already well underway, they decided to implement inventory optimization and the automation of much of the procurement processes associated with that. The feeling was that this would solve those problems of service levels and costs, and it would take a few months to achieve. Now, the optimization systems require two key data sets: the catalogue of materials containing information about different SKUs, and the associated supply chain data, information on pricing, MOQs, consumption, and so on. When the chosen solution provider began to define what was needed, it quickly became clear that those data sets were in an appalling state. The catalogue was haphazard with missing data, incorrect names, a large number of duplicate entries, and data on SKUs that was completely obsolete. The supply chain data was equally bad, with little in the way of consumption data, prices that were years out of date, and minimum order quantities that hadn't changed since they were first entered by the original manufacturer. At the same time, an assessment of the inventory processes found that the picture that the ERP was painting about what was held in the various locations and the tracking of materials from ordering to issue were barely functional. In reality, the firm had little understanding of what it actually held and where it was. As a result, the optimization project was postponed for over a year while the team embarked on a complete data cleansing transformation, cleaning and enriching the data and ensuring that what the systems held corresponded with what was actually on the shelves in reality. That done, the company continued with the optimization and automation projects, and today they're one of the most efficient logistic areas in that region. Around the same time that was happening, a German rail company, Deutsche Bahn, also decided to ride the digital transformation wave, this time attacking the huge costs and lead times associated with its 600,000, yes, 600,000 SKUs. Seeing the opportunities to reduce lead times, reduce MOQs, costs, and improve the availability of their assets, they decided to use 3D printing to produce as many of the spare parts as possible. The first step was to identify which parts to proceed with, spotting for which there was a business case. They hired a very capable data analyst to come in, assess the data, and come up with a short list. After 3 intense months of work, the analyst reported back that the approach was doomed to failure, that the materials data, both physical design and supply chain data, was simply not good enough to do this top-down approach. Instead, the company took a more bottom-up method, sending a tiger team to each of the maintenance location and asking engineers and mechanics what they thought should be 3D printed. As a result, the transformation program was delayed by several months, and the expenditure on that analyst was completely lost. 2 years ago, businesses were already on a path of digital transformation. Digitization of paper-based records and processes, the initial use of robotic process automation, the implementation of data analytics, and the rolling out of ERPs, MMS, WMS, and a raft of other solutions was already underway, all aiming to reap benefits in increased production and operational resilience, as well as reduced costs of operation, of course. After all, so many digital innovation promises nowadays are that they will deliver those benefits and deliver them quickly. Jump forward those 2 years and the operational environment has changed, with increased demand, pushing for higher production levels, and the twin issues of cost optimization and supply chain resilience now at the top of the agenda. As a result, we're seeing the pace of digital transformation accelerate significantly, with plans and projects that were scheduled for the next 5+ years being brought forward and implemented today. However, many of those initiatives will and do fail in the first few steps for one reason: bad data. Now, when I speak of bad data, I'm talking primarily about the data that's at the heart of operations, materials data and supply chain data. And issues that mean that it's bad will be missing data, having the wrong data, such as badly entered or out of date, wrong syntax, common when you're using multiple languages, having the wrong data template. When you need to describe a pump, for example, you need to use different data fields than what you might want for an O seal, for instance. And duplicate entries, having multiple copies of the same item. The impacts of bad data ultimately affect operations, from lowering service levels and increasing costs. So think of the operator who needs a spare and can't find it in the catalogue, so he creates a new item and orders it. The buyer who receives the wrong buy signal and orders more of a part than will be needed for the lifetime of the asset, resulting in higher expenditure, locking in working capital and eventually resulting in higher obsolescence and disposal costs. And that bad data significantly increases the risk of failure of digital transformation, directly as those projects are built on a bad foundation and don't produce the return on investment that their business cases were predicated on. Now, we're all aware nowadays, very well aware, of the need to clean our hands to avoid the risks of COVID. If companies are to mitigate the risks of bad data and succeed in their efforts to digitally transform, then their data must also be cleansed. Get it right, tackling the cleaning of materials and supply chain data early, and digital transformation efforts are more likely to succeed. And better yet, the results of data cleansing are felt operationally and financially almost immediately. Lower inventory holdings, higher productivity, reduced regulatory and fiscal risks all flow from having clean data sets. And the scale of those results far exceeds the costs involved in tackling data cleansing head on. Now, despite those benefits, though, data cleansing is traditionally unloved, something that's not given the attention and resources it needs and deserves. All too often, it's relegated to the "we'll get around to it eventually" list of tasks, or as the Spanish would put it, mañana. When it is addressed, that typically involves assigning a junior data analyst to do something about it. And as a result, the task becomes a case of painting the fourth bridge, the very epitome of a never-ending task. Where they do attack the data, the techniques they use are laborious, repetitive, and slow. And it gets worse. Whilst those inadequate efforts at cleansing data are going on, existing data processes continue to see bad data added, processes that don't ensure that the right data is expressed in the right way, in the right format, and that duplicates are avoided. Where there is a measure of governance in place, it quickly becomes a bottleneck, slowing down the creation of new items and delaying the placing of purchase orders and therefore the availability of equipment and assets. Getting it right involves addressing all of those in a systematic way. Let's consider materials data. First, we need to tackle the cleaning of the data itself. In parallel, we need to redesign the processes that create new data. And in underlying all of that, we need to implement a governance and performance management approach that monitors and controls the health and progress of the entire system. Now, I could go into the details of this in a more theoretical, very dry way, but I do think that bringing this to life with a real case example is probably healthier. So I'm going to hand over to Innokentiy, who's going to talk through a recent case example where we've done just this with an organization. Innokentiy, you're muted.
Sorry, thank you, Len, for this great overview of the importance of data, specifically master data. So let me take you through an example that we've recently delivered to a midlife oil and gas assets. And it was a catalog. Yes, please, thank you. So it's a catalog, a huge catalog of 150K items that is across 4 assets with no proper classification, with all the bad symbols of symptoms of bad data, such as duplicated items, excessive purchase, non-standard naming, and so on. So let me take you through and deep dive into the methodology that we applied in order to deliver some sustainable results. So usually we take the approach in 4 major steps. First things first, we need to develop a document that will regulate all the rules and procedures of cleaning data. Basically, it means if we have an ambiguous situation, we address to this document and understand how we have to treat a specific data, be it a how do we spell a fraction number, how do we spell ranges and standards per units of measurement, and so on. Usually with this document, we also regulate the processes and how to manage the data. In this session, I will not go deep into the actual processes. Let's focus on the actual master data cleansing. So for this, we would have a separate step, which is classification. A classifier, it's usually a tree-like hierarchical structure that ensures that each material throughout the catalog can be easily found and easily navigated across. So we deliver the classifier as a separate work stream during the project. Let's move on to the next one. The next step is developing templates. A template is a collection of attributes when combined form a record that allows to exactly identify this record. Let's deep dive a little bit into that. So on the right-hand side, you can see the actual template example. As you can see, a template motor consists of several attributes such as type, manufacturer, model, power parameters, and so on. So when we have a template, we attach per each item these attributes. So how do we attach template to an item? So there's the insight here. For each item, we first identify a class. Usually it's a noun that is the first defining word of an item. For example, a valve could always will start with the word valve. This way, if we have a data set of 150,000 SKUs, we will end up only having, let's say, 1,000 classes. It eventually helps to improve your timing drastically when you try to attach a template per each material. So once you do that, you will have to define per each template a specific set of attributes. And finally, you will have to decide which attributes are mandatory and required to be filled in order to identify an item exactly. So for example, for a pipe, it would be sizes and diameters and so on. And for a motor, it may well be just the part number. So let's move on to the next stage. Once we define templates per each class of a material and covered the entire data set, we start the cleansing process. Basically, cleansing means taking the existing data and distributing these pieces of data across the templates that we defined on the step before that. So let's deep dive into this process. For cleansing, we use our own proprietary solution that we've developed over time based on the experience we've had implementing projects such as cleansing. This solution combines automated and programmatic methods to clean, but also manual checks of the actual data. In some cases, we use machine learning algorithms in order to perform this task. So let me share with you how we do that and even give you some insights on how this can be done in your organization. So we take a 5-step approach that is displayed on the slide at the moment. So let's go one by one in order to understand how it works. So before jumping into cleansing, what we do, we scan the whole data set for the typical mistakes and errors that are available in every single catalog. We will find up to 10,000 or 20,000 errors just there at the very beginning. These errors can mean non-standard symbols, wrong semantics, double characters of double spaces, or any other misspelling and so on. So this is very important to do beforehand, because once you have the data cleansed, prepared before cleansing, the cleansing would go much more smoother. So let's move on to the next stage. When we have the data prepared, we need to decompose the data into significant blocks. What do I mean by that? We have a string of data, which is an item, any type of material. What we need to do is find and decompose these pieces of data into meaningful blocks, such as classes, types, different characteristics, could be power parameters, temperature parameters, protection class, part numbers, and so on, standards, materials. So we use machine learning algorithms in order to scan the data set and define these characteristics. Once done so, we moved on to the next stage. So here's another insight. Once we have all the blocks defined, what we do, we check those blocks with our internal experts manually in a specific tool. What is important, we don't check data material per material, we check data per attributes. So for example, if you have an attribute power parameters, we would check all power parameters of the entire data set. This way, you can make sure and ensure that all power parameters are in the same standard across the whole data set. So instead of going by material one by one, we check per attributes. And this is a valuable insight that can be used by anyone elsewhere. So once we check and standardize all these attributes, we have the data available in a standard and decomposed way per attributes. So let's move on. Another important activity that we perform during the cleansing is identifying duplicated items. Once we have the data distributed across attributes, it's much easier to identify duplicated items. We can use synonyms to match, for example, nouns. We can disregard the way the part numbers are written, for example, dashes or dots. They would mean the same for our system, but also the format of the numbers, the way they're written. by combining these three factors, we can achieve a considerable result on identifying duplicated items. And let me also share with you why it is so important. The finding and identifying duplicated items is the real source of immediate impact on your procurement and your stock. There, in the bottom of the slide, I'm showing a real example of how this works. Imagine we have two duplicated items. One has an order and stock available on hand. And another duplicated item has another 5 items in stock available. This way, we can see that the person ordering 10 items does not see what is available in the duplicated item, and you end up having an excessive purchase of 5 items. This is a real case, and this happens all the time. So that's why I would like to reinforce this is very important to activity to perform. Let's move on. And finally, when we perform all the cleansing and standardization, find all the duplicated items, we work closely with our clients, end users, the actual users of the data, to validate what has been achieved. We need to make sure that the end users who will be using this day-to-day will be happy with the result, and that they have great improvement on the data they're using in terms of navigating the catalog, in terms of ordering new items, or in terms of creating new items. So this is a typical approach we use, and let me share some results that we've achieved on this project. So in total, we cleansed and standardized 140K SKUs materials. We've developed a 3-level classifier that covers all SKUs to make sure for a better navigation and search. We have identified 5.6 thousand duplicated items, and from these cases of duplicated items, we've achieved almost $1 million savings in 1.5 years in purchase. So identifying and treating those duplicated items easily covers any investment required for projects such as data cleansing. On top of that, we have developed 950 templates with specific attributes per each type of item that, as our client put it, gives us a very good fundamental base to work in the future. I know I haven't touched on the process, but we have also done and redesigned the process of managing this data to make sure that the cleansed data remains cleansed, that we deliver, that we add new items when in a proper way with the standards and without generating more duplicated items. Among other deliverables, we can surely say that up to 50% faster end-to-end cycle time was achieved. And eventually, this project became a platform for further digital transformation projects that are taking place in this organization. I think that's it, and thank you a lot for taking listen on this topic. I would like to hand over to Len.
Thank you very much, Innokentiy. That approach of tackling the data cleansing in detail, step by step, and bringing more certainty as we go through, and at the same time of attacking the process, is typical of how data cleansing can happen now. Moreover, the advent of SaaS-based tools such as Synopps, which integrate with ERPs and other materials data management systems, means that once the data has been cleansed, the system can automatically keep it clean, formatting data on SKUs as it's entered and automatically checking for duplicates. Supply chain data cleansing involves those three activities, from putting the data in the correct format as it's created, ensuring the processes involved in its generation are aligned and consistent, and implementing governance and performance management to monitor and control the quality. One frequent hurdle to overcome with digital transformation is knowing where to start. And we've seen so many different approaches to that depending on which kind of challenges are being faced. Irrespective of what technology or development is used, and data cleansing is very typical of that, data sits at the heart of that success. And having a high quality of data is always a prerequisite for success in those initiatives, whether it's visibility, whether it's optimization, whether it's process mapping, whether it's cost saving. From identifying spare parts to 3D print, to optimizing maintenance and inventory, to automating supply chain processes, clean data is essential. Recognizing that is one of the first steps, followed by assessing the quality of data and where it's found wanting, taking a systematic approach to deal with it. Thank you very much for joining us today. We've hoped you found it useful. If you have any questions or would like to follow up with Innokentiy or myself, our email addresses are there on the screen. Please do get us in touch. We'll be delighted to listen to the challenges you're facing. Thank you.
Thank you, and have a great day.